Hey Math Journey! Have you ever wondered what happens when you take trigonometric functions to really high powers and add them together? Today, we've got a fascinating puzzle involving powers of sine and cosine that'll put your math skills to the test. Alright, here's the challenge. If sine to the power of 10 plus cosine to the power of 10 equals 11 over 36, what about the power of 12? Can we find the answer without complex calculations? Let's dive into a clever shortcut. Before we dive into solving this, take a moment to think about it. What jumps out at you? Can you spot any connections or familiar ideas? Even complex problems often have a simple starting point. Give yourself a few seconds to explore the possibilities, and then we'll solve it together. Let's tackle this problem systematically. First, we define two variables to make things easier. Alpha equals sine squared of x and beta equals cosine squared of x. Since we know from trigonometric identities, sine to the power of 2 plus cosine to the power of 2 equals 1, we can simplify our equations as alpha plus beta equals 1. From the problem, we're told alpha to the power of 5 plus beta to the power of 5 equals 11 over 36. Now, we want to find the value of alpha to the power of 6 plus beta to the power of 6. Alright, now we know what we have and what we need to find. Here's where the magic happens. We'll use a recursive formula for sums of powers to help us find higher powers step by step. To do that, we'll define s of n as alpha to the power of n plus beta to the power of n. By multiplying both sides by alpha plus beta, our recursive relation becomes s of n plus 1 equals alpha plus beta times s of n minus alpha beta times s of n minus 1. Since alpha plus beta equals 1, we can define the product alpha times beta as the variable of m. So, the relation simplifies to s of n plus 1 equals s of n minus m times s of n minus 1. Now, we'll express each subsequent of s of n in terms of m for s1 to s6. To continue, we need to find the actual value of m. Fortunately, we were given that s of 5 equals 11 over 36. We can use this information to solve for m. This gives us this quadratic equation, 1 minus 5m plus 5m squared equals 11 over 36. After rearranging and simplifying, we have m squared minus m plus 5 over 36 equals 0. By solving this quadratic equation, we get two potential values for m, 1/6 and 5 over 6. Now, to determine which one to use, we'll use an important principle which says, for any two positive numbers that add up to a fixed sum, their product is maximized when the numbers are equal. Since alpha plus beta equals 1, the product of alpha and beta reaches its maximum when alpha and beta are both 1/2, which means m cannot be bigger than 1/4. So m is 1/6. Now that we have m equals 1/6, we can substitute it back into our expression for s6, which is 1 minus 6 times m plus 9 times m squared minus 2 times m to the power of 3. With substituting of m, we have s6 as this. So, our final answer is s6 equals 13 over 54. Which means sine to the power of 12 of x plus cosine to the power of 12 of x equals 13 over 54. And that's our solution. If you enjoyed this challenge, don't forget to hit that like button and subscribe to Math Journey for more fun math adventures. Now that you've seen the answer, how did you do? Were you able to crack it? Let me know in the comments. And share this video with a friend who loves brain teasers to see if they can solve it without peeking at the solution.